Hello dear friends, we can solve questions from this question paper. Okay, so we are selecting the questions from the chapter circles and areas related to circles. Please don't forget to hit that subscribe button and turn on notification. Let's begin the class. In the given figure, PQ and PR are tangents to a circle centered at O. If angle QPR equals 35 degree, then angle QOR is equal to QOR. We should find this angle. So you know it's a quadrilateral and this radius to the tangent, this angle is 90 degree. Obviously, the remaining angle will be 180 minus 35, right? 180 minus 35, that is 145 degree. So option D is the correct answer. This is a 1-mark question. Let's move to the second question. If perimeter of given triangle is 38 centimeter, then length AP is equal to. So here we know the circle is there inside the triangle, and we know this P is an external point and BR and BP are tangents to the same point, so tangents to the circle from this same point. So this BP is also 6 centimeter. And here you know CR is 8 centimeter. So definitely CQ will be 8 centimeter. And we have to find the length of AP. So the AP will be equal to AQ. And we know perimeter of the triangle is sum of all the sides, right? So I can write AP plus BP plus BR plus RC plus CQ plus QA, right? And AP we don't know, plus BP is 6 and BR is 6. So I can add it together, 12. RC plus CQ, 8 plus 8, 16 plus QA. And this perimeter is 38 centimeter. AP and QA is equal. So I can write 2AP. 2AP plus 12 plus 16, 28. So 2AP equals 38 minus 28, that is 10 centimeter. So AP will be equals 10 divided by 2, 5 centimeter. So option B is the correct answer. Okay, AP equals AQ. That you should remember. Okay. In two concentric circles, a chord of length 8 cm of the large circle touches the small circle. If the radius of the larger circle is 5 cm, then find the radius of smaller circle. Tangent and radius is making an angle 90 degree, right? And it is a perpendicular, right? It is perpendicular to the chord, so it is bisecting the chord in equal parts. Okay, so AP equals PB, right? Okay, that is AP is equal to PB equals 8 divided by 2, 4 centimeter. And you know this is the radius of the bigger circle. The radius of the bigger circle is given 5 centimeter. It is given 5 centimeter. So you can use the Pythagoras theorem here, and AO square equals OP square plus PA square, right? We don't know OP. AO square is 25 equals OP square plus PA square is 4 square 16. So OP square equals 9. OP will be 3 centimeter. So you got the radius of the small circle. Find the radius of the smaller circle. It is the question. So it is 3 centimeter. In the given figure, PA and PB are tangents to a circle centered at O. Prove that OP bisects angle APB. So angle APB is here. Okay, we have to prove that OP, this line is bisecting, means this angle and this angle are equal. So we should prove that. And second question is OP is the right bisector of AB. Okay, right bisector of AB. So we can consider the triangles. Triangle OAP and triangle OBP. So how can you prove that they are congruent triangles? One reason is this angle. Radius and the tangent are perpendicular to each other. So angle OAP equals angle OBP. Okay, radius perpendicular to tangent. Okay, that's why I could write 90. The angle is same. And OP equals OP. That's a common side, right? OP is the common side. And OA equals OB, radius of the circle. OA and the OB are radius of the circle, so those are equal. So you can use the right RHS criteria for congruence, right? Right angle, hypotenuse, and side. One right angle is same, one right angle is there, and hypotenuse is common. Okay, and one side is matching. Okay, these two triangle OAP and triangle OBP are congruent triangle. So definitely this angle APO and angle BPO will be equal. Okay, so this angle APO and BPO, angle APO equals angle BPO. Hence, we proved OP bisects angle APB. Okay, bisector of triangle AQP and triangle BQP. And here, what are the chances? Here, the angle already we proved this angle, these angles are equal. So one angle is equal, and QP is a common. So side AP equals side BP, right? AP equals BP. So external point, from the external point, when we draw tangents, those are equal. Okay, next one is QP is a common point. Okay, QP is a common side. And then these angles are equal. We proved angle APO and angle BPO are equal. So that those angles are equal. So we can prove, so definitely we understand a triangle AQP and triangle AQP is congruent to triangle BQP. So definitely these sides will be equal. AQ equals QB. Therefore, we can write AQ equals QB. Okay. So we proved the OP is bisecting the line AB. Okay. AQ, OP is bisecting AB. And what about this angles? Okay. These angles are equal and this is a linear pair of angles, right? So this, as this is a straight line, the total should be 180 degree. So one angle should be 90 degree, correct? So angles AOP and BOP are 90 degrees. AOP equals angle BOP equals 90 degree. So we can say it's a right bisector. Hence, OP is right bisector of AB. Prove that the lengths of tangents drawn from an external point to a circle are equal. So we should prove PQ equals PR. Okay, so here also we just prove these triangles are congruent. Triangle OQP congruent to triangle ORP. We should prove this. How to prove? We can say this angle, okay, angle OQP equals angle ORP. So this is radius and this is a tangent. Okay, this radius and tangent are making 90 degrees. So these angles are equal. Next we can write OP is a common point, right? OP equals OP, that is common side. Common side. And OQ equals OR. OQ equals OR, that is radius of the circle. Okay, now we can understand angles are equal, two sides are equal, and hypotenuse, RHS criterion, right? Right angle, hypotenuse, and side, RHS criterion we can use, and we can understand that triangle OQP congruent to triangle ORP. Triangle OQP congruent to triangle ORP. So we can easily write QP equals PR, or PQ equals PR. Corresponding part of congruent triangles. Corresponding part of congruent triangles. The perimeter of a sector OACB, OACB of the circle centered at O and radius 24 centimeter is 73.12. Find the central angle AOB. So we should find this angle first, angle AOB. Okay, so perimeter of OACB, that means it is the length of ACB, right? Plus length of ACB plus 2 times radius. One radius is this, other radius is this. So we can write 2 times radius. Okay, that is 73.12 equals length of the length of ACB. How can you find? It's a perimeter of this part, right? ACB. So we can find that is theta divided by 360 degree times 2 pi r. Please comment if you have confusion in this equation. I will explain. Plus 2r, 2 times 24. So instead of r, I can write 24. Okay. So 73.12 equals theta divided by 360 times 2 pi r. Okay. Plus 48, and 73.12 minus 48 equals, okay, 4 pi theta divided by 30, and theta equals 25.12 times 15 divided by 2 times 3.14. Instead of pi, you can keep the value 3.14. So this is 2 and this is 15. When it comes 15 times 25.12 divided by 2 times 3.14, we will get 60 degree. Okay. And have you noticed this angle is 60 degree and this OA and OB are equal? So we know two things. One angle is 60 degree and OA and OB are equal. So if we consider this as an isosceles triangle, triangle OAB, this angle should be equal, right? Angle OAB and angle OBA should be equal, right? So in a triangle, the sum of angles are 180 degree minus 2 theta, that is 60 degree. So 2 theta equals 180 minus 60, 120, and it is 60 degree again. So these two angles are also 60 degree. So this triangle is an equilateral triangle. So for the equilateral triangle, you know the area of equilateral triangle. How can you find? Root 3 by 4 a square. A is one side. Root 3 by 4, 24 square. Okay. And we can find area of the minor segment ACB. The question is area of the minor segment ACB, this segment. So if you know the complete area AOCB, that segment, you can subtract the area of triangle, you will get this areas, this minor segment's area, correct? So we can write area of minor segment ACB equals area of sector minus area of triangle. So this area, you know the equation, theta divided by 360 times pi r square minus root 3 by 4 a square. Okay, so 60 degree divided by 360 times 3.14 into 24 square minus root 3 by 4 24 square. Okay, when I calculate this, I will get 52.32 centimeter square. Okay, hope you understand. Please calculate this thing. Okay, you will get the answer. Thank you.